Part C, find the particular solution y equals f of x to the given differential equation with the initial condition f of 2 equals 3. So it's one of these problems that are usually worth 5 or 6 points, and we just sort of go through the same process and be careful at the end. So we start off with our differential equation, dy dx equals y squared over x minus 1. And if I didn't have this y over here, I could just try to do the antiderivative straight away. But since there are y's and x's, I want to separate the variables. So get all of the y's to one side, all of the x's to the other, including sort of the dy and the dx. So I'm going to divide both sides by y squared and multiply by dx. So I get dy over y squared equals dx over x minus 1. And multiplying both sides by dx moves this out of here and goes to the numerator. Dividing by y squared gets that there. All right, and that's separating variables. Next thing, I need to take the antiderivatives to get rid of this dy and this dx. And in here, for this one, the easiest way to deal with this is probably to think of it as the antiderivative of y to the negative second dy. And this one, I mean, I can do it straight away. I could use u substitution. I don't actually need to use u substitution. I'll talk about that briefly. But let's find this first. So the antiderivative of y to the negative second, well, you add 1 to the exponent and get y to the negative first. And then you divide by this exponent, so over negative 1. And I'm going to have a constant c1. Over here, this works almost exactly like the antiderivative of 1 over x, which is going to be the natural log of the absolute value of x minus 1 plus c2. Now, I don't usually show both of these when I'm actually doing the work, but I want to make sure it's clear that we get constants of integration from both. This works out this way because I could do u substitution. Let u equal x minus 1, du equals dx, and antiderivative of 1 over u is natural log of absolute value of u. I can move the constant of integration both over to one side, so I get negative 1 over y. That's what this will be when I move the y to the denominator and divide out the negative 1. I'm going to subtract constant from both sides, and I get natural log of the absolute value of x minus 1 plus a single arbitrary constant. If I take an arbitrary constant, subtract another arbitrary constant, it will be a third arbitrary constant. So I usually wouldn't write both these. I just put the c in. That should be fine for the AP test as well. All right, next thing I like to do is I like to put in the 2 and the 3 and figure out what c has to be. You can do some work first and do it later. I do it here, so I make sure to get the right c value. I'm going to bring this up here so I have some more room to work because there's plenty more to do here. So I put 2 in for x, 3 in for y. I get negative 1 over 3 equals the natural log of the absolute value of 2 minus 1 plus c. 2 minus 1 is 1. Natural log of 1 is 0. So c is going to be negative 1/3. Put it back in, and I get, see, I'm running short on colors to use. So I get negative 1 over y equals natural log of the absolute value of x minus 1 minus 1/3. And I need to go ahead and do some work on this. So I want to solve for y. So we're going to divide out a negative 1. So I have positive 1 over y equals 1/3 minus natural log of the absolute value of x minus 1. So this one becomes negative, this one becomes positive. I flipped it around so I have less to write. I only write a negative and a plus. And I can sort of flip the whole fraction. I'll show it a different way and I'll explain what I meant by that next. I'm going to multiply both sides by y and get 1 equals 1/3 minus the natural log of the absolute value of x minus 1 times y, and then divide both sides by this and get y equals 1/1/3 minus the natural log of the absolute value of x minus 1. And that's what I meant. If I flip this 1/y as y/1, then all of this over 1 becomes 1 over all of that. A common mistake would be people try to write 3 minus 1 over natural log. It doesn't work that way. You have to flip the entire side. There is one last thing to consider, and that is this. And it's probably the trickiest thing to remember here. This is undefined at x equals 1. And we're given a point to the right of x equals 1. The way differential equations work is this. If we go over a point where this is undefined, we can't know anything past that point because the way that the derivative works, I could actually restart anywhere. So this is the equation, but I only know what happens to the right of 1.